Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about how to implement a stack using arrays. Now, see here. First of all, you want to know about what is meant by stack, right? Okay, so just take for example, it is a stack. So in stack, we use a last in first out technique or first in last out technique. Okay, let me tell you what it means. First of all, I am pushing 1 to a stack. Now I am pushing something like 10 to a stack. Now 2 to a stack. Now 3 to a stack. When I'm popping it out, this top value is popped out. So the which value I lastly inserted will be popped out first. Which value I inserted first will be popped out at last. Can you understand this? First this 3 will be popped out, then 2, then 10, then only 1. Can you understand this? So this is the stack data structure. Now we are using an array to implement the stack. Okay, we can see how to implement it. So we have some operations in stack. Those are push, pop, friend, empty, and length. So these are the operations we can do in stack. So we can see how to implement this all operations using this array. Okay, initially I take an array like this. Okay, let me take this array sizes 5. Let me take array sizes 5. Okay, so this is going to be act like a stack. Okay, to visualize it, I can use a stack. This is for your understanding only, but we have only this array. Okay, now initially I place a top pointer here, which is equal to -1. Top pointer will be pointing to what? A -1. Okay, hold on. Now, at first, let me give some operations like push. First of all, I am pushing 1. So let us take this all example. Okay, now I am pushing what? 1. So if I push 1 in the stack contains 1, right? So I will make this top as what? +1 is equal to 0. So now my top pointing to this 0, right? And I put what? 1 here. Can you understand this? Okay, again I am giving push 10. So if I push 10, it will be like here it comes 10, right? Okay, now I will increment my top and go to here and write what? 10. Now again I am giving what? A 2. So 2 will be placed here, right? So again I will make my top pointer move here and place 2. Now again I am pushing 3. Now I make this top pointer move here and make one 3. And here also it will be 3. Now take for example, I am popping out. What should I do now? So if I'm popping out, see here, what is the top value? It is 3, right? So we want to return this 3. So here also, what is my value? This 3 will be popped out, right? So my output will be something like 3. And I want to make this pointer to move here. This pointer to move here. Take for example, again I am pushing some value like 4. Then here comes 4, right? Here my top will be going to here. My top will be going to the next in this, and this 3 will be updated as what? 4. Can you understand this? I haven't deleted. I just moved and making that what? Making that as a modified value as the recent value. I'm updating the value. That's it. Can you understand this? Okay, fine. Now, if I'm doing a front operation, again. So in my front operation, what is the first element in the stack? It is 4, right? So we want to give output as 4 without deleting it. You don't want to delete this 4, right? So I can say the top element's value is my front. Can you understand this? So to find the front, I can say ARR is an array. Take for example, ARR is the array, then of top. So this is the front element, right? Simple. Okay. Now, if I want to check whether it is empty, so whether this array is empty, no. If this array is empty, then my top will be what? Top will be -1. So I can say if top is equal to -1, then I can say it is empty. Okay. Now how to find the length? So my top pointer is standing at where? Standing at this third in this. So I can say I have 3 plus 1 is equal to 4. So 4 is my length of the stack. Right? Okay. Now take for example, I am popping out. So if I pop out, this 4 will be popped out and 4 will be my answer. Now here, what should I do? I should make my pointer to move one step behind, right? So I move my top pointer here. Let me change the color. Okay, now top pointer will be here. Now if I again do a length, Okay, now what is the length? 2 plus 1 is equal to 3. Can you understand this? This 4 is not included. Right? So this is the length. So we completely completed what? This empty and length. Still we have what? this front is also completed. Okay, in this front we have one edge case. What does edge case? If take for example, top is pointing to what? Pointing to -1. Top is pointing to -1, and if I do a front operation, then what should be my result? Stack is empty. Stack is empty. I should return what? Stack is empty. Or I should print what? Stack is empty. Okay, now this front is also finished. Now, what about this pop? Okay, take for example, I'm doing a pop operation here. Okay, if I do a pop operation, this 2 will be outside, and here also I make my temp pointer to move here. Sorry, top pointer to move here, and output the 2. Can you understand this? Okay, again I am using this pop operation. Then this 10 will be popped out, and this top pointer will move here after printing this 10, right? Okay, now 10 is also in my output. Now again I am doing this pop operation. Then this 1 will be popped out, and this 1 is also this 1 is also printed, and this top will goes to what? Top also go to -1. -1. Again I am doing pop operation. My stack is underflow. Technically it is what? Stack underflow. See here, stack underflow, which means my stack is empty and I cannot do any pop operation. So when my top is equal to -1, then when I am doing a pop operation, I should do what? Stack underflow. Stack underflow. So it looks like clumsy, right? So when I am writing a code, it is so clean. You can understand what it states, right? Okay, now let us take another example. Like I have an array of size only 3. Okay, now if I have something like I want to insert a value 10. Okay, I am inserting a value 10. So top is here. Now I want to insert 20. So I will insert 20 and top is here. Now I want to insert something like 2. Then my top is here. I insert it. Now if I want to insert something like 100, whether I can insert here? Whether I can insert here? No, right? So when my array is full, which means when my stack is full, I cannot further add anything. I cannot push anything. So this condition is technically called as what? Stack overflow. Overflow. Can you understand this? So this condition is what? Stack overflow. When to find the stack is overflow? When my top is pointing to what? My top is pointing to n-1. N is the length and n-1. If it is the condition, then I should return what? Stack overflow. I should print it. Right? So this is the edge case for the push operation. So we successfully completed all this 5 operation, right? Now it's time to see the code. When we are seeing the code, it is so simple. See here. First I included the whole libraries. Now using namespace std. Okay. Now int top is equal to -1. Inside top is what? -1. And I am taking the n is what? 10. So my length of that array is what? 10. Now I am declaring the array also. Now void push. What should I do in push operation? In push operation, I want to push the element when it is not full. The stack is not full. So I am just checking whether stack is full. If it is so, I just return what? I just return empty, and I want to do what? I should print stack is full. Okay, stack overflow. Now I will do what? ARR of plus top is equal to val, which means what? Which means first increment. If top is equal to -1, then first increment it will be 0. Then at the 0th index, place val. Hope you understand this. Yes. Now int pop off. So in pop method, what should I do? I should first check whether top is equal to -1. If it is so, I want to do what? Just count. Sorry. Just see out what? Stack is empty. Stack is empty, which means what? Stack is underflow. Okay. Now top minus, which means what? I'm just do a minus, and I just return what? Array of top plus 1, which means what? The next value. The next value, what is the value? I want to just return it. Can you understand this? So this should be the pop operation. Okay. Now here we can also return it, right? If there is no more condition, just return -1. So I can return like this, such that the condition is fulfilled, right? When my stack is empty, I just return -1. Other than that, I will return the value. That's the case here, right? Okay. Now int of array. So I want the front element. For that also, I want to check whether the stack is empty. If it is so, I just return -1 and just stating that stack is empty. Now return ARR of top. So I am just returning the top element. Okay. Now bool of is empty. So I want to check whether top is equal to -1. If it is true, I want to return true. If it is false, I want to return false. That's it. Okay. int length. For length, I have written what? Top plus 1. I clearly stated in the drawing explanation itself, right? Okay, now I'm doing some operation like push ARR of 10. So I'm pushing 10, then I'm pushing 5, then I'm pushing what? 20. So let me write here. So initially I'm pushing what? At 10, then 5, then 20, right? So this is the pushing value. Now pop value. So I am popping out from ARR. So while I'm popping out, what should be my answer? It should be a 20. So my output will be something like, first it will be 20. Okay, then front of ARR. So what is the front value? It is 5. We don't want to pop it. We just printing it. So it is 5. Then again front. It will be what? Again 5 only. Okay, now I'm printing what? The length. Okay, what is the length of the stack? It is 2. Okay, now again I'm checking whether it is empty. So I want to do what? An empty operation. So it is false, right? So we will print a false. So this is my output, right? Okay, let us check whether this is the output for this. So let me run it. See here, pop value is 20, print value is 5, again 5, again length is equal to, now empty is equal to 0, which means what? It is false. Can you understand this? Okay, now use this same code and try the stack overflow and also stack underflow condition, so that you can clearly observe how this stack works. Okay, now we have already seen how to implement the stack using the array, right? So basically, to implement a stack, we have two methods. What are they? One is array method. Another one is linked list. Okay, we have saw that we successfully implement by using what? Array. Then why we are implementing by this linked list? What is the purpose of this? So the implementation of the linked list is basically like in array, if I have array size of 5, then I can store only these 5 elements, right? But in linked list, I can store how many elements I want. It is like what? A dynamic, right? It allows what? Dynamic memory allocation. So dynamic memory allocation. So by using this property, we are using what? This linked list. Can you understand this? So this is the disadvantage of this array. In array, it is what? A fixed size. But in linked list, it is an advantage. We can do a dynamic memory allocation. Right? So this is why we don't do this array implementation. We use what? Linked list. If you want this linked list, I will give the link in the description. Just go and watch it. Now, the important stuff that you have to know is what is the time required to insert or delete or do some operations. Okay. What is the time required? I can say the time is constant, right? Because we haven't used any loops, right? We haven't used any for loop, we haven't used any do while, we haven't used any while, so we haven't used any loops. We are using what? Only the if conditions, right? So if condition is what? A constant operation. That's why my each and every operation is what? Of time constant of 1. So this is the best optimization, right? So that's why we are just implementing what? The stack using array. And also in linked list that the same time constant will be occurred. Yes, thank you.